Welcome to this video. Today I'm going to be talking about how to convert from pH to concentration and from concentration to pH. In a few seconds, here's a summary of this video. First, we're going to do practice problems involving finding the pH from the concentration. Then we're going to do the opposite and find the concentration from the pH. Finally, I will give you some practice problems so you can check your progress on this topic. Alright, so how do we find the pH from the concentration? Well, it turns out we use an equation. And this equation says that pH is equal to the negative log times the concentration of the hydronium ion. And the hydronium ion concentration may also be written as the concentration of the H+ ion. They both mean the same thing. Okay, so what you're going to do given the concentration is you're going to say, okay, pH is equal to the negative log multiplied by the value of the concentration. With the equation in mind, try this one on your own. If the concentration of sulfuric acid were 0.25 m, what would its pH value be? So first we just want to keep in mind that m is molarity, a measure of concentration, and we want to find pH. So we can say that the concentration of the hydronium ion is equal to 0.25, and we need to find pH, which is going to be equal to the negative log times the concentration, which is 0.25. Now just a quick note, when you see this, the brackets mean concentration, and whatever's inside is the concentration that you're measuring. So in this case, we're measuring the concentration of the hydronium ion, which is a measure of acidity. Now for these next few problems, we're going to find the pH given the concentration. So for this first one, we have the concentration of the hydronium ion, and that is going to be equal to 6.991. So to find pH, we use the equation. So pH is equal to the negative log of the concentration, so that's 6.991. Now just put this into a calculator and you will get negative 0.845 for the pH. Let's do this next one here. So molarity is equal to 1.778. Alright, so to find pH, we know that pH is equal to the negative log of the concentration. In this case, it's given in molarity, so we're just going to do of 1.778. If you do this, you get negative 0.2499 for the pH. Now going down here, the concentration of the H+ ion is given as 0.0043. So the pH is equal to the negative log of that concentration. Negative log of 0.0043 is equal to 2.367. Now for this last one, we have a concentration of 0.00029, and so the pH is going to be equal to the negative log of this concentration. Calculating this, you get 3.54 for the pH. Alright, so that's how to calculate pH. You're going to set the equation equal to pH equals negative log and plug in whatever the concentration value is. And as you can see, the concentration might be given as the hydronium concentration, the H+ ion concentration, the molarity, or just the word concentration. Alright, so now, how do we find the concentration from the pH? What equation do we use? Well, it turns out we use this equation. We're going to say that the concentration of the hydronium ion is equal to 10 to the negative pH. This means that if you were given pH and asked to find concentration, you will say, okay, I know that concentration is equal to 10 raised to the negative pH value. Again, because H3O+ and H+ can be used interchangeably, you might see that this equation is actually H+ in brackets is equal to 10 to the negative pH. They are both saying the same thing, okay? They are both trying to find the acidity concentration given a pH value. Alright, so in these examples, we want to find the concentration, given the pH values. So for this first one, we have a pH of 7.4. And so we know that the H3O+ concentration is going to be equal to 10 to the negative pH value. So that's going to be of the negative 7.4. Doing this, you get 3.98 times 10 to the negative 8 as your concentration. Now let's do this one over here. So the pH is 1.002, and so we know that the concentration is going to be equal to 10 to the negative pH value, so the negative form of this number. Okay, so we just put a negative sign in front of the pH value and calculate. Now, what answer do you get? Well, you get 9.95 times 10 to the negative 2 for the concentration. So let's move on to this one here. So the pH value is given as 3.81. Okay, so the concentration of hydronium ions is equal to 10 to the negative pH. This is going to be to the negative 3.81. Take a moment to put this into your calculator and see what you get. So you will get 1.55 times 10 to the negative 4 for the concentration of hydronium ions. Finally, we have this one over here. So try this one on your own. What is the concentration when you have a pH value of 11.5? Alright, so the concentration of hydronium ions is going to be equal to 10 to the negative pH, so negative 11.5. Putting this into your calculator, you will get 3.16 times 10 to the negative 12 for the concentration. So this was how to calculate the concentration from the pH. You're going to use the concentration equation, which says a concentration is equal to 10 raised to the negative pH value. As a little bonus to this video, I am adding acid strength trends with pH and concentration of the H+ or H0+ ion. So what is the trend with acid strength and pH and concentration? Well, it turns out that as acid strength increases, pH is going to decrease, which means that stronger acids are going to have lower pH values. Now, what is the trend with acid strength and concentration? So what is going to happen when acid strength increases? What is the concentration going to do? Well, the concentration of the H+ or H0+ ions, okay, so I put this in brackets, is going to increase as well. So a higher concentration of these ions is going to tell you that you have a stronger acid. Which makes sense, because according to the Arrhenius definition of an acid will contribute the hydronium ions, or H3O+ ions, to a solution. Acid strength and pH are indirectly related, meaning that as one goes up, the other has to go down. And acid strength and concentration of the hydronium or H+ ion are directly related, meaning as one goes up, the other one also goes up. Now it's time for you to check your progress with converting between pH and concentration. So for the first one, you're going to be finding the pH. For the second one, you're going to be finding concentration. And for the last one, you're going to be using some of the bonus information that I just provided. And as usual, you can leave your answer in the comments. Thank you so much for watching this video. I really hope you found it helpful. If you did, make sure that you subscribe, and I'll see you next time.